Let's try another one. So for this one, I'm looking for a GCF again, and I don't see one this time. So I'm going to jump right into factoring. I notice that I have 3 terms, so that means I need to use my quadratic form, which in my case means I'm going to do an X box. And you probably knew that because I have an X box drawn here. But let's go ahead and fill in our X box. Now this one is a little bit tricky because it has an X to the 4th power. This isn't actually a quadratic, it's a quartic, but we learned how to do that when we were factoring. We just need to change up our exponents a little bit as we go along, so we'll talk about that. A times C is 16, 1 times 16, and negative 8 is my B value. So I'm looking for factors of 16 that add to be negative 8. That means I need a negative and a negative. Knowing that, I'm going to start with negative 1 and negative 16, negative 2, negative 8, negative 4, and that's it. The ones that actually solve my puzzle, negative 4 and negative 4. So when I write these, I'm going to say negative 4. Normally I would write x, but this time I'm going to write x squared, and let me show you why. Remember that these 2 pieces kind of correspond to this middle term. Remember, we're trying to get 2 things that add to be a negative 8x squared. So I have to have an x squared here and here in order to match, and then my first and last terms go here. So x to the 4th, not an x squared, but an x to the 4th, and a 16. Now I treat this the same way that I have previously. I'm going to find the greatest common factor. X squared and a negative 4. Going down the first column, I also have an x squared in common between x to the 4th and negative 4x squared. And then another negative 4, remembering that these negatives occur because the box that I'm writing next to has a negative in it. So now we can rewrite our original equation in factored form, or somewhat factored form. We'll have to see if we need to do anything more. So remember that these are x squareds because I had an x to the 4th, and I'm kind of splitting that up here. Okay, so now what we need to do is see if we can factor any more. I see x squared minus 4. This has 2 terms with a negative sign between them. Both terms are perfect squares. Look at your flow chart and you will know that we need to use difference of 2 squares. And so let's come down here below our x box to do that. So I'm going to say difference of squares is the next technique that I'm going to use. The other thing that I want you to notice is that this and this are the same. So whatever I do to this one, I'm just going to do the same thing again. So technically I'm using difference of squares twice. So to take care of the first x squared minus 4, remember that we put our x's in the front. We say what our square root of 4 is, which is a 2. Or we can ask ourselves what multiplied by itself will give me a 4, and that's 2. One of these gets a plus and one gets a minus. So that takes care of the first one. I need to do this whole thing again because I have the exact same piece again. So another x plus 2 and x minus 2. Don't forget that second one. Now I need to see if I'm done or if I can factor more. And I notice that every one of these terms is linear, so that means that I'm done with factoring. However, there is a way to simplify this and make it look a little neater. And so what we're going to do is say x plus 2 is actually squared, because remember the definition of squaring something is taking something like x plus 2 and multiplying it by itself. And then I can do the same thing with the x minus 2 and square that and say that that is equal to 0. So again, this is just a simplify step. This is also going to allow us to identify repeated solutions like we talked about at the very beginning. So I want to set each of my factors equal to 0. I have an x plus 2 factor and an x minus 2 factor. And so when I subtract 2 from both sides, this will give me x is equal to negative 2. When I add 2 to both sides, this will give me that x is equal to a positive 2. We want to remember, though, that both of these were stated twice. We have a squared here. So we will identify these as repeated solutions, or RS, and with an even power. So that even power means that we are going to bounce on our graph. And that's going to become important here in just a minute when we do graph. In order to graph, we need to know a couple more pieces of information. We know that we have x of negative 2 and x of positive 2. We also know that our y-intercept, let's go ahead and mark that, is at 16. This is my y-intercept. The y-intercept of 16 is going to be way up here somewhere. This isn't to scale, but I'm just going to mark that as 16. And then let's go ahead and identify our key pieces of information. My degree is 4, which is even. My lead coefficient is positive because it's that positive 1 in front of x to the 4th. So that is a positive. And so that means my arrows, well, this one on the right goes up because the lead coefficient that's positive says up. Even says the left does the same thing. So I want my arrow going up on the left and going up on the right. And remember that I need to bounce at negative 2 and at positive 2. So it's going to look something like this. I'm going to come down and go up to 16, come back down, hit negative 2, and keep going up. So that's what we mean by bounce. Let's go ahead and label this as a bounce. That means that the solution occurred twice.